Right, hello guys. So we are still continuing with Chatellier's principle. Just a recap, we said Chatellier's principle states that if the conditions of a system in equilibrium, conditions such as temperature, pressure, and concentration are changed, the equilibrium is going to be disturbed. So when the equilibrium is disturbed, what does it do? It counteracts the disturbance, it opposes the disturbance, and then it re-establishes a new equilibrium. So here we are actually looking at the application of Chatellier's principle. So we are talking about the common ion effect. So I just want us to take a look at this equation here, where we have cobaltous chloride and water reacting to form hydrated cobalt and then chloride ions, and then we are told that delta H for this equation is less than 0, which means it is negative. So we already know by now that this implies that the forward reaction is exothermic, because this statement that is written here, it actually represents the forward reaction. So it actually tells us that the forward reaction is exothermic, which means the backward reaction is endothermic. So here, when we are applying the common ion effect, we have two colors here. If we favor the backward reaction, it means we are going to produce more of these two once the backward is favored or the reverse is favored. So we are actually going to see our solution changing to blue. The solution is going to change to a blue color. Is it okay? But if we favor the forward reaction, the solution is going to change to pink. So that is very important. So what we are going to be observing as we do this experimental demonstration is that there will be color changes that we observe. So when we cause a disturbance, we are actually going to observe a color change. So we call it the common ion effect because we have common ions. We have chloride ions on the right, we have chloride ions also on the left, although they are combined with the cobalt. So let us explain what happens now. So let us say the question says to you, what is the effect of adding hydrochloric acid? So if you add hydrochloric acid, we know that this hydrochloric acid in the solution, it is going to ionize to produce H plus in aqueous solution and Cl minus in aqueous solution. We know this. So we know that our hydrochloric acid in the solution is going to produce these two ions. It is going to produce hydroxyl ions and chloride ions. Are we together there? Now, when this happens, what does that mean? It means we have actually increased the concentration of chloride ions in the solution. So Cl minus concentration is going to increase. Are we together there? Now, when Cl minus concentration increases, according to Chatellier's principle, when the system is disturbed, we have disturbed the system. Remember, we said we are talking about three conditions here. We are talking about conditions of temperature. We are talking about concentration. And we are talking about the third condition of pressure. But we said pressure only applies when we have gases, because the pressure of gases is the one that changes. Liquids and solids, the pressure does not change. We are not concerned about the pressure. So here we have to ask ourselves, when we add hydrochloric acid, what exactly are we doing? We are increasing the concentration of chloride ions in the solution. So we are actually playing around with concentration there. It is not pressure, it is not temperature. We are changing the concentration. So when we increase the concentration of chloride ions, the system is going to oppose. How does it oppose? It opposes by favoring the reaction which tries to reduce the concentration of the chloride ions. So the reaction that is going to be favored there is the one that reduces the concentration of Cl minus. Remember, we have increased the concentration of Cl minus. So the system is going to oppose by trying to reduce the concentration of Cl minus. How does it reduce the concentration of Cl minus? It favors the backward reaction. So when it favors the backward reaction, it means the solution will become blue in color. So this is what we are going to observe. We are going to observe that the solution changes color to blue, or it becomes blue in color. That is after we add HCl. Or if it was already blue, we are going to see that it does not change its color. So it means when we add Cl minus ions into the solution, the system opposes by favoring the reverse reaction, which reduces the concentration of the Cl minus which you have added. Therefore, the solution is going to change to blue. That is very important. It is a key point there. Are we okay? So that is how we answer that question. But you can't just say the solution will become blue. You are not going to get full marks. You need to explain that according to Chatelier, the system will oppose where HCl, when it is fed into the solution, it produces chloride ions. Therefore, we are going to have a high concentration of chloride ions. So in order to oppose, the system is going to favor the reverse reaction in order to try and reduce the concentration of the Cl minus ions, and therefore the solution is going to come to change color to become blue. I hope that is clear there. Now let us say we now increase the temperature. That is sub question number 2. So when we increase the temperature, we are now guided by this part of the equation, the part where the enthalpy change is written. So this enthalpy change is the one that guides us. So here we can actually see that the forward is exothermic, the backward is therefore endothermic. So when we increase the temperature, the system is going to oppose by favoring the reaction which absorbs heat. And the reaction which absorbs heat is the endothermic reaction, which is the backward reaction. So again, it is going to change to blue. So it will become blue because the backward is going to be favored. Hope it is making sense. Let me just repeat that very quickly. I'm saying we have two half reactions here. We have the forward reaction, which is exothermic. We are guided by this statement. Remember, I said before, the statement that you are given here, it indicates or it represents the forward reaction. So the opposite of that represents the backward reaction. So if we increase the temperature now, when we increase the temperature, the system will try and absorb heat in order to reduce temperature. So which reaction between the two, the forward and the backward, absorbs heat? It is the endothermic. The backward reaction, it absorbs heat. Therefore, it is the one that is going to be favored. So the solution is going to change to become blue in color. I hope that is okay. Right. Then what if we now add silver nitrate? When we do a topic called qualitative analysis, where we test for ions in a solution, we make use of silver nitrate. Why do we make use of silver nitrate? We make use of silver nitrate because the solution, we know that silver nitrate is going to give us silver ions and nitrate ions. That is what happens in solution. Then, when I look at this equation now, what do the silver ions do? The silver ions that have been produced here are going to combine or are going to react with the chloride ions to form silver chloride, which is a precipitate, which you can actually observe. So it means by adding silver nitrate, what are we doing? The silver nitrate is going to react with our chloride ions. So when it reacts with our chloride ions, it means the chloride ions are getting finished because they are reacting with the silver nitrate. They are reacting with the silver part of the silver nitrate. So we are going to see a decrease in the concentration of the chloride ions because they will be reacting with the silver nitrate. So adding silver nitrate actually means reducing the concentration of the chloride ions. So when we reduce the concentration of the chloride ions, what does the system do? The system opposes. How does it oppose? By favoring the reaction which increases the concentration of chloride ions that we have reduced. the system will oppose by trying to increase. So we are going to find that the forward reaction is going to be favored. So when the forward reaction is favored, the solution tends to pink. That is very important there. Are we together there? Then when you check the documents that you use for study, you're going to see a lot of things can be added. So I was just giving you an example there. We can add sulfuric acid. And you remember, even in organic chemistry, when we deal with equations that involve, or reactions that involve water, we know that it is, the molecules of water are held together by hydrogen bonds. There is a special type of intermolecular force between water molecules that is known as a hydrogen bond. So it is the one intermolecular force that is very strong. The strength of that intermolecular force is 30% that of the covalent bond. So the hydrogen bonds in water account for its irregular properties. Amongst other things, we know that water is a rare liquid, which when it freezes, it becomes less dense. That is why ice floats on liquid water. It is because of those hydrogen bonds, amongst other things. We'll look at the properties of water or the chemistry of water some other time. But you should have already covered it in the previous grades. So whenever we have a reaction that involves water, we make use of a strong acid. We can use sulfuric acid. We can also use phosphoric acid. Why do we use sulfuric acid? Sulfuric acid is a dehydrating agent. It removes water, which means if we have an equation like this one, once we add sulfuric acid, we are actually removing the water. So when we remove the water, how does the system respond? It responds by trying to replace the water, so the backward will be favored. So you need to be very careful. When sulfuric acid is added, it means we are trying to remove the water. Sometimes we can add strong bases like sodium hydroxide and potassium hydroxide. So what does these ones do? When we add a base like sodium hydroxide in a solution, it is going to dissociate like this. So sodium hydroxide is going to produce, okay, let's start like this. So sodium hydroxide in a solution, it is going to give us sodium and hydroxide ions like that. This is a hydrogen ion, this is a hydroxyl ion. So let's not confuse the two. So this is what happens. Sodium hydroxide, we are going to have Na plus and OH minus ions. Now, these OH minus ions in solution, let us say in our equation, okay, we don't have one like that, but you're going to meet some like that. Let's say in our equation, we're having H plus ions somewhere. So once OH minus has been produced and then we are having H plus somewhere there, it means that H plus is going to react with OH minus in order to produce water. So we need to remember that the moment we add these strong bases, we are actually removing the H plus ions, if they were H plus ions. Are we together there? So we need to be very careful of that as well. So that is how we reason with Chattelier's principle using the common ion effect. Are we together there? It can also apply in terms of pressure if we are having gases, but I think it's clear for now. All right, good.